Hello and good afternoon. How's everyone doing today? Hope everyone got a great lunch. And thanks for coming to our session today. My name is Doug Booth, and I am a Principal Business Development Manager for Amazon Web Services. I work with our customer, Amazon.com. So we are two different organizations, and so I spend a lot of time supporting Amazon.com on their usage of AWS, as well as their database and data lake solutions, which also covers analytics. Today, we're going to have Craig Woods and Naveen Yajman from Business Data Technologies come out and speak to you all about analytics at scale. We're going to talk a little bit about our past data warehouse and how we deprecate it in favor of a new data lake, okay? And agenda-wise today, we're going to cover some of the legacy Oracle data warehouse challenges we had. We're going to cover some of the big data system goals we had, talk about the big data architecture, and then a bit on the migration from a legacy environment to a new way of doing things. And with that, I would like to invite out onto the stage Naveen Yajman, Senior Manager at Amazon.com. Naveen?
Thank you, Doug. Good afternoon, everyone. Thank you for being here. So today, as Doug mentioned, we are going to focus on how we do analytics at Amazon at scale. So what I would like to start with is share with you a little bit about the landscape from an analytics perspective within Amazon.com, and then transition a little bit over to present more technical deep dive, and then we cover some of the user experience, and then move from there. So first of all, I would like to mention that Amazon.com is a customer of AWS, very similar to a lot of you here. We use the same public interfaces that you all use. We use the same documentation tools. We have an AWS account team that we interface through with AWS. More importantly, we use our use cases to push AWS to innovate for all its customers. So we push the AWS technologies to the limit, and we are going to talk to a lot of those examples in the transformation that we did. Like many of your organizations, Amazon.com is a globally distributed business. There are lots of business units globally. They produce a lot of data. We have users spread out in all these global business units who utilize that data to make decisions to meet their customer needs. For the last 20+ years, these users have been using one of the world's largest Oracle data warehouses to meet their analytics needs. Similar to many enterprises, we have a very diverse user group. We have data engineers, we have software engineers, we have data scientists, we have business analysts who perform varying set of tasks as it relates to analytics. They do batch reporting, they do machine learning, they do exploratory analysis. In our legacy data warehouse, which was an Oracle data warehouse, we had over 38,000 tables. And many of these tables were curated master data sets that we made available to a lot of our users. The users, which were about 80,000 active users, they were running about 900,000 jobs daily. So this kind of gives you a perspective of the scale of the analytics environment that we were running in our legacy data warehouse. And this will actually help you kind of relate to the transition and the challenges as you go through the transformation like we did to move to AWS-based technologies. The legacy data warehouse stopped meeting our needs, so we invested quite heavily in specialized hardware, fast routers, switches, and so on. It continued to get expensive. And there were some fundamental challenges with the data warehouse itself. One of the primary challenges was the data and the compute were coupled. So there were, as our data continued to grow year over year, we had to add a lot of compute hardware. It became not only expensive, it became unreliable, and our engineers spent hundreds of hours patching these systems, moving data around just to keep the system running. And at the same time, our hardware was to be scaled to peak, and there was no way we could get the type of hardware that we were using on demand. And on top of that, the licensing continued to become expensive. So we needed something better, and something soon. So we invested in building what we call Project Andes. This was an AWS-based data lake. This was prior to a lot of the innovation that is happening in AWS around data lake formation, something that you guys have probably heard, and this was launched in last reInvent. So our investment started several years ago. The goals for Project Andes and the Andes system, first and foremost, is to decouple data from compute. So our data could grow independent of compute. So we used S3 for persisting our data. So S3 allowed us to store massive volumes of data reliably, securely, and cost-effectively. The next goal was to basically adhere to an open systems architecture. So this meant that our businesses could use the data processing technology that made sense for them. They could use any of the AWS data processing technologies like Redshift or EMR, and as, of course, AWS continued to innovate Redshift Spectrum, for example. The next goal was, of course, to leverage AWS technologies, made sure that we continue to push the limits on AWS technologies so they continue to innovate and make the innovations available to all our customers. We were coming from a traditional relational data warehousing model. So we wanted to make sure that our new tech stack that we built supported not only the relational data warehousing model, but also support the big data use cases that our customers were starting to use. So with this, you kind of have a little bit of context about what was the landscape that we were dealing with. Next, we are going to go deeper into the technology, the stack that we built, how we solved the problems from a technical perspective, some of the decisions that we made in order to address and meet these objectives. I'm going to invite to stage Craig Woods, who is a senior solution architect who was responsible for a lot of the technical decisions that we made, and he's going to go deeper into the technology stack, and I'll come back later to talk about some of the user experience pieces. Craig?
Thank you very much, Naveen. As Naveen said, I'm Craig Woods. I am a senior solutions architect with the Business Data Technologies team. Naveen and I both worked closely on the project that we undertook to develop Andes and then to migrate the entire company to Andes and then fully deprecate the Oracle system. This was a daunting challenge. It's one that is unparalleled in my career and one that was highly successful. And I wanted to go into some of the reasons that we were so successful. Here's a quick summary of our legacy environment. We had some advantages in our legacy environment because we were cheating a little bit. This already looked a little bit like a lake if you squint and look at it carefully. It was a single fleet that hosted all of the data. A lot of Oracle servers, we had all the data in one place. There was only one environment. It was not broken out into staging and prod. We did not have a separate ETL environment, a separate analysis environment, a separate interactive or ad hoc reporting, or even a separate reporting environment. This was a single environment, all the data in one place, and it was an ELT environment or architecture, extract, load, transform. What that means is that all of the jobs in this environment were SQL. SQL is something that you can migrate relatively simply. Ha ha ha. It's not that simple, of course. SQL is different everywhere you look. But it is just SQL. We didn't have to deal with Python and Scala and third-party tool integrations with business objects or other reporting front ends. This one environment we were able to treat like a data lake style environment in our legacy system. Everyone would run extract jobs, transform their data, and load it back into the warehouse again, and then another pass of transforms could happen. Data would then be exported out of the system to downstream systems for more intricate data tasks like business automation, ML, and reporting systems. So, as Naveen mentioned, we wanted to preserve this pattern, this ELT pattern of this quasi-lake that we had, but move the back-end storage off of the bounded systems that were the Oracle, which could no longer keep up with our data. Our jobs were just too slow, and move into a more open environment. And so one of the ways we kept ourselves, helped ourselves be successful was this idea of managing the scope of this migration. We only migrated this environment, not all of the downstream work, for example. We also took some other decisions. This is tabular data. We chose not to move to full support for semi-structured data. Many of you are probably dealing with semi-structured data sets in your environment, and we certainly are. There's a demand for it. But in order to keep the complexity of our migration bounded, we decided to defer that for post-migration enhancements to the platform. Similarly, we decided streaming was out of scope. This is batch. The new system would still be batch. We will add streaming around the edges initially, and then we would add core support for it as the system matures. And finally, the other major scope limitation that we decided was our primary target would be Redshift, shared compute environments on Redshift clusters. We did this because the single central model was too cumbersome to scale for a business as large and as diverse as Amazon. We needed teams to own their own hardware, to make their own decisions about scaling, about investing in their analytics environments, and their own decisions about which technologies to choose. We knew that Redshift would be the anchor of that. That would be the place where most of the jobs ran. We enabled EMR. That was also our goal, but we did not build out EMR infrastructure ourselves. We, again, chose to make that a separate technology project and investment that we would make at a later time. Here's where we started, and here's what we built to make our Andes Data Lake successful. The boxes you see on the left are similar to what we had on the previous. We kept all of our workflow systems. So we enhanced them so that they could understand how to talk to S3 in addition to Oracle. But we kept the old system largely running. And then we added in a bunch of other services that we would use to manage the data in S3. These services we call Andes. It started at the top with a UI that customers could interact with that would be able to find those data sets in S3. They'd be able to change and modify data sets by adding columns or changing schema. You could version and deprecate data sets in a coherent way. This is very important because we also changed sort of what the data set means, and I'll talk about that a little bit here. We don't just have a single file sitting in S3. We also need to move that data out to Redshift, and it's going to exist potentially on many Redshift servers. These interfaces for managing the data sets in Andes would also coherently propagate those changes out to the clusters. So that was the core of our data lake, was this set of services over top of S3 that allowed us, the way we thought about it was it allowed us to treat the files in S3 as if they were tables. That we had a lot of the same management and administrative properties you can use in an Oracle database type of environment and treat them like tables. One of the important things we also got out of that is the ability to have merge semantics in our data sets. If you've worked with S3, you understand that data is append-only in an S3 model. You keep adding data to the system, but when you get multiple versions of the same record, they're just sitting in different files. All the versions are still sitting there. This system, we built into our writes into the storage system a workflow that wrote that data out and then compacts it and creates a merged version or view for customers so that they could then do compute on that in S3. And similarly, when we propagate the data out to Redshift, we would do the merge as the data arrived at the Redshift cluster, and so it would be able to appear as if there was a merge happening on Redshift. For those of you who have worked with Redshift, you would know that Redshift doesn't support enforcement of primary keys. And primary key and merge is a very powerful semantic, and we decided that was important enough that we built our own merge logic on top of the Redshift logic, so that we would delete the old records and insert the new version so that there would still appear to be a primary key and a unique primary key with no duplication. So we were able to use these services to emulate the behavior of our legacy data warehouse in using the S3 backend. One of the big pieces of this here is a box that you see that says subscription service in the middle of the right-hand side. The subscription service was what we used to propagate the data or the metadata for our data sets as changes occurred out to this distributed analytics environment across Amazon. Thousands, literally thousands of distinct environments across Amazon are consuming the data and using that data locally within their business unit, just the data they need. They can filter the data for rows or columns. They can pull that data out to their own local resources. If they need more storage, they just add more storage. If they need more compute, they add more compute. If they prefer Redshift, they use Redshift. We integrated with AWS Glue Catalog, if you look just below the Redshift there. And the AWS Glue Catalog was our center point of our non-relational approach to data access. Many of you should be familiar with EMR, Elastic MapReduce. The Elastic MapReduce infrastructure is in wide use across Amazon. We have a very sophisticated engineering culture, software engineering culture, and engineers prefer and understand and can manage EMR as a delivery platform for analytics. And so we integrated with AWS Glue, and that allowed anyone with an EMR cluster to then start doing analytics directly on the data in S3 without needing to synchronize. The synchronizers for Glue moved only the metadata. Whenever we added new blocks or new bytes to the system, the metadata pointing to those new blocks or bytes was added to the Glue catalogs so that the users could consume the data. And then the last target we did have in scope for our initial migration was AWS Redshift Spectrum. Redshift Spectrum, you can see, is really Glue plus Redshift in some ways, if you think about it. Glue integrated, or Redshift integrated with Glue, well, that was really convenient for us. I'll talk a little more about that later, that story, but we were able to synchronize data sets on a Redshift cluster that, where users were using Spectrum for that data as well. Now, the key to this synchronization and subscription service, in addition to the decentralized nature of it, was that it was also orchestrated or sequenced along with the job sequencing. So we had a single orchestration tool that was our core orchestration tool, and it knew when data was refreshed and when that refresh had propagated to each of the targets, so that the jobs could be triggered on those targets only once the data had arrived on that target. If one target got behind, the jobs would wait for the data to arrive before they ran. So this coordinated, integrated orchestration system was the heart of our legacy, and we were able to integrate that and extend that through out to these distributed environments using our subscription service. Pardon me. So once we had that stood up and we started people migrating, we were able to disable or deprecate the legacy Oracle environment. I'll go through a little bit of the technical challenges of getting that migration from point A to point B, but once we kept the same infrastructure and we were able to simply turn off Oracle, and eventually we are only running on S3 as our backing store, and the subscription service and the distributed analytics environment all running on AWS services. So this was a huge accomplishment, but as Naveen mentioned, we had 80,000, I always chuckle when I say that number, that's bigger than the town I live in, right? 80,000 users using this system on a daily basis, tens of thousands of data sets being refreshed in synchronization throughout the day globally, and 1 million jobs running. All of that had to be migrated across to new technologies, EMR and Redshift. So let's talk a little bit about how we made that happen, or what made that possible to do in less than 2 years. It's an astonishing accomplishment, right? So the key to that, the sequence that we used here, was very technically challenging, and it was a somewhat risky endeavor, but we decided this was the best overall path forward for us. We built out our metadata service and governance service, and then we built a data mover. The data mover moved the data, very elegant name, from Oracle over to S3 in the new formats that we had developed. And the loads, we modified our load strategy such that loads would happen to both systems in parallel. Our goal was to be able to run both warehouses, both versions of the warehouse, legacy and the new one, in parallel for an extended period of time. Now that was really hard. if any of you have tried to keep things in sync on different platforms with different data representations, wow, that's really hard. And to keep the data being refreshed constantly in both systems and catch failures in one place that don't happen in the other and recover and backfill, it was not trivial. This was a very difficult challenge. And I'll say, if I was doing it again, I'd give us a B maybe, or a B- on that particular part. I wish we had done this better, right? But it was our first time and hopefully our last time. And it was good enough to get us through. And it was easier, or what it made easier was migrating the jobs. Migrating the jobs is the real hard part here. 1 million jobs and 80,000 users is big. It's massive. There's momentum there. There's inertia, right? We had to train people on the new technologies. We had to convert their SQL over. We had to get them to troubleshoot that, validate that, verify that, and turn it off, all within a fixed period of time. So we did decide that a very good investment here was a query conversion tool. Actually, let me step back a second. The reason that we did the data mover was this step was uncoupled or decoupled. We didn't go and build a Gantt chart the size of an entire wall of our office, with every environment and every data set, and this is going to move here and that's going to move there, and everybody has to be off this one by that particular time. That was viewed as intractably complex and would just be impossible to manage. So instead, we ran everything in parallel, and we set a very broad window and said, all right, every team out there is going to migrate within this window, and all of their jobs have to be off by this time. There were some small gradations in there where we took some low priority tables and said, okay, those are going to go away a little bit earlier. And then some medium priority tables will go away closer to the deadline. And finally, only at the very end would we start to deprecate the most utilized data sets with the biggest impact. So we did some soft coordinating steps like that. But overall, it was very, very decoupled and decentralized. Individual teams had to set up and manage their own burn downs of jobs to migrate. And we helped them by building a query conversion tool. Let's talk about AWS here for a second. When we built our data mover, we looked at something you've probably heard of called data migration service, database migration service, DMS, from AWS. We tested it, and it wasn't ready for the scale and complexity of what we were trying to do. It didn't have the bandwidth and volume, and there were other technical challenges. We weren't able to use that. We had to build our own tool for that particular stage. Keep in mind, this was very early in the project, and that was 3 or 4 years ago now, right? So we didn't get to use DMS for our data mover. But for the query conversion, DMS also had something called this SCT, the schema conversion tool. We evaluated that, and we found that it did a pretty good job of converting Oracle SQL to Redshift SQL. We used that library. We wrapped it in some testing tools for users to use for bulk conversions. We actually did dry runs of the entire thing. We looked for exceptions that were raised where the conversions failed. We drilled down on those. We found what was causing the failure. We often fixed it and then pushed those changes back to Redshift and said, hey guys, here's some improvements for your tool that can get the conversion percentages higher. By the end of this process, we had that automated conversion as high as 90% of the queries that were being converted successfully automatically on the first pass. So we were able to use that query conversion tool, and we got most of the jobs migrated, and then my favorite part of the talk, we got to the last 10%. Now, if anyone here has done a big migration like this, you know that the last 10% is super easy, right? Oh, you guys don't believe me. You're right. It's not, of course. This is all the people who didn't want to migrate or who didn't have time to migrate, or worse yet, were looking for features that weren't there in the new system. There are feature gaps, I assure you, right? It's not a perfect replica. We're still building this tool. It's been a full year since we launched, and we're still making improvements to this tool to make it more useful for the business. So we braced ourselves. We built in padding and cushioning on this and said, OK, we've got time. We'll be ready for all those escalation emails. We didn't get the escalation emails. We got brag emails. People saying, hey, Vice President, we're done early. hey, come to our launch party. We've launched and we're deprecating all of our jobs on the legacy data warehouse. Brag, 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 every single one. We got one team that said, we can't hit the deadline. Remember those numbers up there? 85,000 users, 30, I don't know how many teams. One team came to us and said, we need extra time. And we said, how much? And they said, about a week. Is that okay? We said, yes, that's okay. A week is fine. We had 3 months built in the back end, just in case. 1 week. At the end of that week, we had 0 jobs running on our legacy data warehouse. Nothing. Every single user migrated. This was a little strange. We actually went out and talked to customers. I personally could not believe this, right? This is just weird. I've done technology for a long time. That's not how this works, right? How did you guys do this? They had come to us in the middle of the project and said, we can't solve X, Y, and Z. You guys need to build that. And we said, you know what? That's out of scope. We can't do it. And so we waited for them to come and say, well, X, Y, and Z is going to break us. And we went back to them and said, you said X, Y, and Z was going to break you, and we didn't build X, Y, and Z. What happened? They said, well, we fixed it. We spun up a cluster, we loaded the data in there, we ran some transforms, we had a guy write some code, and a Scala code, and an EMR fleet. We ran the job through there, and then we loaded the data in. So we solved it. Don't worry about it. We're good. And by the way, we helped this other team, too, that had that same problem, and we're sharing that code now, and it's working great. Wow, right? We used to be the bottleneck for the entire company on technology. We were the data warehouse. We were the, we don't say that word anymore, it's not allowed, but we were the data warehouse, right? And if we didn't build it, it didn't happen. And here we had this massive migration with massive risk for the entire company, and it was a breeze. I've got people back there who are going to throw things at me. It wasn't a breeze. There was a lot of blood, sweat, and tears, a lot of really hard work here, and a lot of risk that we had to manage. But people were able to solve and troubleshoot their own way out of problems without coming to a central team because AWS makes that possible, right? You can spin up a cluster. You can just run stuff. It's that easy. So that was a revelation for me, really, and I think for our whole team and our whole organization. And within a week of all the jobs being off, we had literally powered off all of those Oracle clusters. They were no longer in operation. All the data on them was gone, and we sent people to start dismantling the system. So that's what it looked like to go through this process and how we strategized to minimize risk and maximize our success probabilities, and some of the tools that we used. Let me describe some in more detail our metadata service here. Now, as a caveat, this is an internal Amazon tool. This is not AWS technology. We, as I mentioned earlier, we were a little ahead of some of the technology developments in AWS, and I'll talk a little bit about how we were surprised by some of them. Some of what we do does influence AWS when we come to them and say, here's a problem, and maybe here's how we've solved it, and they may take some of that into consideration when they're developing their services. But this really is just our solution today, and so don't count on seeing this on any release notes or launch notifications during reInvent this year. I mentioned earlier, we've got the Andy service with synchronization primitives. This allows us, this is where we write the data out and we keep track of the data as it arrives, and we are able to propagate that data coherently and in coordinated fashion out to many different targets for computing. It also is where we implemented the merge semantics that allows us to keep track of primary keys in these data sets and mimic the behavior of a merge on a relational data store, which was critical to our overall ELT workflow. We have something we call a completion service, which is very useful. I mentioned that we've got this one global orchestration tool that's very powerful and very useful, but it's not perfect, and it is a little old. It was written a long time ago. And so there are better tools out there. There are new tools out there. Glue is now an orchestration service, but even things like Airflow. Many of our customers want to be able to use those tools to run their businesses, not their analytics workflows, not just our core service. So we built this completion service as a way, as a bus, if you will, so that different orchestration tools can coordinate updates, not to the same data set, that's bad, that's a bad idea, but from step to step in workflows that move from tool to tool they can use this completion service to say, I've updated a specific logical update, regardless of what system is doing those updates. And we've got people using Glue and Airflow, for example, as well as custom orchestration written for EMR fleets. We built a concept of a manifest. This is just, it allows us to sort of bundle changes, where changes are being made to many different files. We'll bundle all of the changes for that file into a manifest that's basically a list of the ARNs for the buckets or the files that are being updated in that update. There's also metadata in the manifest that's very useful. The metadata actually captures some of the merge semantics, for example, in that. So these manifests, we partnered with Redshift for this, for example, so that we used the same manifest spec that the Redshift team published, and we helped influence that spec. And that means that we were able to integrate with Spectrum. And again, I'll talk a little bit more about Spectrum in a minute. But so the manifest was a key sort of abstraction that we put over the raw updates in S3 that allowed us to have smoother orchestration. It gives us some performance optimization because we can change the size of files when we need to. And then also gives us better integration with tools like Spectrum. Access management and governance. I'm sure most of you are spending a lot of time, blood, sweat, and tears on access management and governance for data analytics. We're still working on this, but this layer of our metadata service gives us control over access to the data and allows us to implement strong access control and governance tools. And as I say, we're still investing here. This isn't done by any means, but having this abstraction layer was a very powerful way to implement that. And finally, I have up here audit logging for changes. That's really a bad way of saying lineage. We have the ability to trace and track what happened to updating, what job was used to update a given, to write a given update, and we do store and record all of that information to assist with operational troubleshooting, as well as discovery and data engineering efforts for teams who are working on the data as it flows through this environment. In addition to the core service, we built a subscription service. This is a very, very powerful tool, and I think it's a really important pattern to understand as you're thinking about analytics at scale, at the scale that we're talking about. There's no one fleet, no one system, no one solution that can actually manage all the compute requirements for your analytics. Even if you have a single central S3-backed lake, you can have that. But the compute side of the house really needs to have far more diversity and far more capability than one solution can provide. And so we built the subscription service so that the data could be propagated coherently, consistently out to all of these different targets. A subscription, as we define it, included both the contract, which is metadata about governance, who can access the data, what sort of data is in this system, security, and then also SLAs. So that it actually you declare, is it something where you're going to refresh every hour, or do you accept Sev2s or pages for your tickets? Synchronization is the other partner piece of the contract, and this is the actual mechanism by which data is moved, or metadata is moved to bring the data out to the systems out there. And it's important to note, we do also propagate schema changes, as I mentioned earlier, and this is really important too. If I add a column and I have to backfill that column, how do I do that in a distributed environment where that data has been replicated to many different fleets? That's part of the schema of the subscription service. We're still working on this, don't get me wrong. There's challenges here because you can tend to have to move an awful lot of data to implement relatively small changes on big tables. That's still a technical challenge. We still struggle with that. We're still looking for optimization and tuning on that. Anyone who is interested in that, come talk to me afterwards. Just kidding. That was a job recruiting joke, if it wasn't clear. And it was definitely a joke. All right, so this was what we built into the subscription service, and it's proven to be very, very successful, and we've been able to extend it. Synchronize our targets. I talked earlier about our decision to move to Redshift. Let's expand on that a little bit. EMR is fully decoupled storage and compute. That's the ideal that we talked about earlier. Redshift, initially, certainly when we started this project, isn't that. It's still coupled, right? You still move the data onto the server, and if you want to make that server bigger, you add both compute and storage to that system. So why would we choose Amazon Redshift as our near-term target? The answer is our customers, our users. They were used to, and the bar was set to be, all you needed to do was write a query, an Oracle query, in order to do full-blown data engineering. All of our pipelines, that's all people had to do. That was a very low bar, and deliberately so. Not GUI low. You still had to write the SQL. You still had to know the syntax. You still had to understand the data. But that was the bar. Moving to EMR is hard compared to that. You do need to understand something about the clusters and the servers and how much memory is configured and how many workers you have and whether you've got skew in your data files. Right? All of those things are part of the performance and behavior of the system when you're running a query. And when things break, you have to troubleshoot at that grain. That's a much higher technical bar. Our software engineering teams can do that without thinking, right? Without blinking. That's easy. But we had 85,000 customers. Most of those customers are not software engineers. Deliberately so. We like that pattern. That's a very powerful pattern. Anyone can access the data. That simplifies and shortens your chains for answering questions, right? You don't have to hand off requirements to someone. You just simply sit down, write the query, and get the data yourself. That's powerful, and we needed to preserve that. Redshift gave us that level of support for customer requirements. It was far more comfortable transition for our users, and that was what we wanted to set that as our basic target. So Redshift is used largely for shared compute fleets, as I've mentioned, which is our primary delivery channel. But I want to mention that we also do ETL. Obviously, in an ELT system, the difference between ETL and queries is pretty fuzzy, right? There's not a strong, bright white line between an ETL job and a non-ETL job. They're all queries, right? Now, there are differences. You scan more data with ETL, all the columns, for example. They're expensive. But really, they're expensive no matter where you run them. They're expensive on EMR, too. It's just, OK, some people prefer to run those on EMR. For us, we don't differentiate. ELT run, our transforms run on Redshift just as much as our regular jobs do. So that's a strategy that we've deployed. And then AWS Glue. As I mentioned, we enabled AWS Glue access. In fact, some teams were so excited, one team went out and built their own fleet of EMR with integration into our orchestration tool, and they built it out as a shared compute fleet that anyone could just walk up and write a query for. It was a fantastic thing to do. They weren't part of our team. This was just something that they thought they needed to build, and they thought it was cool, and they built it. And in fact, we later merged with them and said, yeah, this is cool, and it has become a corporate enterprise resource of an EMR fleet for running shared compute. So earlier I said that this was a bigger lift, and it still is a bit of a bigger lift. You still have some of those technical challenges, but this team has started to try to make Glue easier to use for individual users, and we're seeing huge uptake and adoption there as well. And so we're running ETL fleets, but they're also running shared compute fleets there. And the final part of my talk is going to be Amazon Spectrum, and I'll talk about that in a second. But on this slide, I think the important takeaway is we are not choosing anymore. We used to be the only tool that you could use was Oracle, and that was our job, to make it as useful as possible. That's not our job anymore. Our job is to run the data orchestration, the job orchestration and the storing your data and letting you manipulate that and all of that. It's up to teams to make their own choices. We've enabled and opened up the tools selection process. And that the uptake on this, obviously we migrated everyone, but even beyond that, since the migration, we've seen more than double in the number of data sets and the number of jobs that are running on this system, because the tools are so much more open and available. This is the last slide in my part of the talk. And this is about how we leverage Redshift Spectrum, or how we think about it. And it's a story it's a little bit of parable about AWS and how to work with AWS successfully. Redshift Spectrum launched in the middle of our project. We were able to get into Glue. Glue launched at the very beginning of our project, and we pushed them pretty hard. They did not want us as their first customer. we caused them a lot of pain. They grew, and they've adapted, and now we're very happy with Glue. And so we were able to leverage Glue, and I told you we got half of DMS. You know, we couldn't use the migration service itself. At that time, it wasn't ready for us, but we did get the schema conversion tool. And Redshift sort of landed right in the middle of our project, right? We had stood up a few Redshift clusters. We were moving data onto those clusters. A couple people had migrated jobs. It was the hardest part. You know, we had all the bugs and all the roadmap was red, and we were fighting our timelines, and it was just a mess. And suddenly Redshift Spectrum launches, right? Spectrum's amazing. If you start with just the Redshift cluster, fully coupled storage and compute, and you add Spectrum, the ability to use external tables where the data stays in S3 until you query it, and only bring back the data needed for that query to the cluster, and they do pre-compute for you outside the cluster. This is almost the best of both worlds. I've coined the phrase semi-coupled storage and compute. It brings the data that you need locally for high performance, but allows you to reference bigger data sets externally. We knew immediately that we had to have this, that this was the missing piece for our whole architecture. We knew that this was going to open up Spectrum far more widely across our business. So we actually did the work to integrate this into our plan. We shifted our roadmaps around. We added some new technology on the back end that manifest stuff. We had to coordinate that with Redshift. We did all of that work, and it really was a crucial factor to the success of the project overall. So be ready, I think, is one of the things when you're doing analytics on the cloud. The cloud moves much, much faster than you could possibly move your own technology stack. You get things, I'll say, for free. AWS invented that for us. We didn't ask them for it. We didn't even know it was coming. It surprised us, and we were delighted with this new feature. We had to shift. We had to devote resources to it, but it really hugely improved our success criteria. So that's a quick summary of how we use analytics on the technical side and how we migrated to a fully AWS-backed analytics environment, not just a single solution, but an entire environment across Amazon. I'm going to bring Naveen back out, and he'll talk about how we managed the migration of the people and the processes in order to make this all work.
Thank you, Craig. So Craig went into a lot of the detail from a technology perspective. He gave you a view into the tech stack. So what I'm going to do is I'm going to summarize in the context of the user experience, number one. I'll show you some of the user experience of Andy, so you'll be able to relate back to a lot of the concepts that Craig mentioned. And then I'm going to go into the program experience of how we made this journey from our legacy data warehouse to an Andy's, which was an AWS-based data lake. So let's start with the user experience. As a user, when I use Andy's, the view that I get is I have all the thousands of tables that I have the option to look up. I can search for the table I'm interested in. I get the details of the table. This includes a lot of the details that Craig was talking about, versioning and all these concepts. So I can decide, okay, I want to use this particular table. Then as I dig deeper, so I can see a little bit more of the information. One of the key pieces of information that Craig kind of referred to is there are a lot of source systems that publish data. And one of the pieces of information that is really useful as an end user is the completeness of the data within a particular data set or a table that you plan to use. So we provide that information so you can then make decision about what is the freshness of the data in this particular data set that I would like to use. Then we talked about the schema, the attributes of that particular table. I can look at this and determine whether this particular table or data set contains the information that I am interested in for my analytics or for any of the other purposes that I would like to use this data set. Once you have determined that, you would want to probably see what are the various subscriptions. Subscription is the concept of ensuring that the data in the lake is synced back into your compute target. So I can look at all the different subscriptions. Then if I were to determine, okay, this is the data set I would like to use, has the relevant information, and if I am authorized, and again, this goes back to the concept of permissioning and governance that we talked about. So this is baked into the data lake infrastructure itself. So if I'm authorized, I can subscribe this particular data set to the target of my interest. So in the case of Redshift, I would be subscribing and the data would get synced along with the metadata. In the case of, let's say, EMR or Redshift Spectrum, the metadata would get synced into the catalog. So once I set up the subscription, I made sure that I'm able to now use and perform my processing. There are lots of other concepts that Craig kind of touched on, which includes things like load, provider, and all these concepts, those are all exposed through this particular interface. And the idea behind this, the layout was to make sure that the most relevant information is available to our users. And there is a lot more deeper dive that you can do using this interface. So we wanted to give you kind of a flavor of some of the key concepts. So with this, you've kind of seen both the technology side of the house, you've seen the user experience. So over the next few minutes, what I would like to do is basically walk you through the journey that we went through, going from a legacy implementation to an AWS-based implementation. So the concepts and the takeaways that you can have are going to be equally applicable to a migration or any technological transformation that you would want to drive within your organization. So first off, from a context perspective, all of you know when you are driving any kind of technical transformation, business does not stop. We have to make sure that we continue to meet the expectations of our users, the needs of our users, so our users continue to perform analytics during the migration. So we had to make sure that the systems were available for them to do that. Next, we realized very much that we will need to retrain our users because a lot of the new solutions built on Andes required it to be run on, say, Redshift or EMR, and a lot of our users were not familiar with those technologies. So we had to make sure that there were appropriate training resources from that perspective. The next big change for all of the business units and the organizations was the fact that what was centrally driven infrastructure and cost management was now something that they had to take on. They had to adapt their procurement processes. They had to adapt to how they manage the resources as well. I'll talk about some of the challenges and some of the takeaways that you would want to have that we went through. So migration is not simple. There are several different moving parts. I think we have kind of outlined that quite a bit through the entire talk. There are a lot of risks, but there are definitely different approaches and strategies that you could adopt to mitigate those risks. In our case, we focused on three aspects. First, we set up a central program management team. The program management team drove the program company-wide. We also, in order to scale the program, we set up a network of what we call single points of contact for each business unit. The SPOCs were the glue between the central team and the business unit during the program execution. The central team made sure that the SPOCs had up-to-date information so they can make sure that their business units not only were unblocked, but were executing to the plan. Next, we talked about the scale. And one of the key things that we did was we invested heavily in automation. And one of the things that we had to approach as a problem was we had about 200,000 queries that needed to be translated from Oracle to a target system like Redshift, or in many cases, people were doing a complete redesign to EMR. So we invested in building our tool set around the AWS schema conversion tool, and we had a lot of success with that, and I'm going to share some of the details later. The next piece was, as I mentioned, the solutions needed to be redesigned. So we set up a solution architect team. Our solution architecture team worked with various business units to analyze their solution designs, make sure that they were doing the right things from a decision perspective. In addition, our solution architecture team also conducted a lot of training sessions for our end users and our engineers around designing systems, implementing systems, tuning systems, and also operating these systems effectively. They also built a bunch of tools around how do you do capacity modeling, for example. This was a concept that many of the teams were not aware of. So our solution architecture team stepped up and did a lot of those things. So there were several takeaways from our effort. And by the way, a lot of these takeaways are applicable not just to the migration, but also to any technological transformation that you're going to drive. So let's walk through some of the takeaways. First and foremost, you need to get buy-in, both from your leadership and also from all of the teams that are involved. The leadership buy-in is going to be critical because that's going to trigger a lot of these efforts, and you are going to invariably run into a lot of challenges, and you will need your leadership support to overcome them. Next, users will always think of migration or any kind of technological transformation as an overhead, over and beyond what they are already doing. So we focused heavily on eliminating as much of the burden on our users as possible. So two things that we explicitly did. One was to invest in the migration tools for queries and also validation. So we worked with the AWS team to improve the schema conversion tool to the point where we were getting about 95% conversion success for queries without any manual effort. And this added up quite a bit. This saved us over 100% years of effort during the transition. The second place where we invested heavily from a migration tooling perspective was in the data mover. As Craig kind of mentioned, we were moving petabytes of data. We were moving about 50 to close to 75 petabytes of data. And so we needed automation in that space. And so we invested heavily in creating automated tooling that allowed us to move the data between the old system and the new system in a reliable manner. And we put in a lot of data quality checks as we did that to ensure that the quality of the data that landed in the new system met or exceeded the bar that we had in the old system. The next thing is you need to plan to run your old system and the new system in parallel. Because a data warehouse is an ecosystem. There are teams that are publishing data, there are teams that are consuming data, and it's a fact that there are going to be teams that are going to move at different velocities when it comes to any kind of transformation. So in our case, we had over 1,700 different teams that were publishing data into the data warehouse. We had over 3,000 teams that were consuming data. And it was not possible for us to coordinate all of the efforts of all these different teams and make sure that they're all driving to one plan. So what we did was we used a couple of different strategies. The first strategy was we identified about 20,000 data sets that were most actively used. We moved those data sets to the new system. And again, we used our automation to do that. Then we made sure that we kept the old system and the new system up to date, again, through automation. So that allowed us to actually start moving the consumers to the new system. And then over a period of time, as more consumers moved to the new system, we started putting in policy and controls to prevent any new workloads being added to the old system. And we did that almost 6 months before the deadline for the migration to be completed. So that way, any new workloads were getting into the new system. As more and more users moved to the new system, we started shutting down parts of the old system. So this kind of became a virtuous cycle to the point where we were able to accelerate the whole migration, and we were able to complete the migration effort ahead of schedule. So this was a key contributing factor to that. The next thing is your users and your engineers will need retraining. And we recognize this fact that we needed to make sure that they had adequate resources to be using the cloud technologies in an effective manner. So we leveraged a lot of the AWS training resources, and our solution architects work with our AWS account team to put together training sessions for our engineers. We made sure that our engineers were getting certified, so that way they were able to then go and train the other users in actually managing the infrastructure as well, in addition to, of course, the automation. Last but not least, communication in this case is an aspect that cannot be overemphasized. So we knew going in that we will have a lot of different challenges. We took a very high-touch communication model and applied it to this exercise. So we used all different channels to drive the communication, including we had a weekly sync with every single business unit to make sure that they were unblocked, or if they were running into issues, our solution architecture team stepped in. And on top of that, we had a community of engineers who are solving problems and sharing those solutions with the broader set of users. So that way, we basically kind of put in what I would call accelerators in place to make sure that the migration moved faster. With all these efforts, and with the efforts of a lot of teams across Amazon.com, we were able to shut down one of the world's largest Oracle data warehouses on November 1st, 2018. This was about an 18-month effort to drive this thing down. Andes has been fully operational and taking all of the analytics loads for Amazon.com for the last 12 months. It's actually gone through several peak events, including last year's holidays. It also went through the Prime Day and this year's Cyber Monday as well. So it has withstood the test of time. And we are super happy with the investments that we have made, because it has allowed our businesses to now rethink the way they do analytics and use the tool that makes sense for them, which is kind of the fundamental aspect of AWS. The other thing that I would like to mention is there were a lot of announcements about the new capabilities in Redshift, and I would highly encourage you all to take a look at that. A lot of the things that we talked about in the talk, you will be able to relate to some of the innovations that the Redshift team announced this morning in Andy's keynote. So with that, I would like to bring back Doug to conclude.
All right, thank you, Naveen. So let's discuss some of the outcomes and how Amazon worked with AWS. That's a big, important part of the equation in accomplishing things this big, this fast. We're also going to review a few case studies and lessons learned, from a project. It's always important to learn what you can from big projects like this, and hopefully come share it with the rest of the world. Outcome-wise, Amazon leveraged AWS services that enabled analytics and big data processing at massive enterprise scale. It was one of the biggest data warehouses in the world. We're running a bigger data lake with more traffic, and it's growing every day. We think a big part of it was, Amazon S3 is reliable, scalable, and cost-effective for storage. Also, the open systems architecture AWS offers allows choice of compute technology, and that's been something that people really have come to us and said they wanted. AWS services chose and also dynamically scale for hardware cost optimization. That's really big for us. When we have peak events like Cyber Monday, Black Friday, digital peak events, during Christmas, Alexa's call home for the first time. So we have to have a lot of capacity to handle these temporary influxes of data. Analytics and data lake infrastructure cost transition from a CapEx to an OpEx expenditure model, which was another key part of the business requirement. And this one I love here. Amazon is able to successfully run an AWS-based data lake with hundreds of petabytes of data with over 300,000 daily analytic jobs, and that's at the low end. It can scale much higher, and that's just where we are today. It's gonna get bigger, and as new features come out for Redshift and other services, it will also get better. Amazon was also able to expand the analytics tool sets to serve more customer requirements. That's really important. It turned out the former data warehouse wasn't the most efficient. Sometimes it was slow. We don't have those problems today. And then AWS solutions enabled engineers to work on innovation versus keeping the lights on, right? We need them innovating and helping our customers, and we don't think keeping the lights on is always the best use of time for that. And managed services also helps take some of that load off. No more refreshing the data center gear. None of that, all of it goes away. The patch management, it's included. So managed services on the database side, like Aurora, like a Redshift, like a DynamoDB, really add a lot of value to the equation and allow builders to continue to build. Next, working with AWS. I would encourage you, if you have a relationship with AWS, partner with your business development manager, their solutions architects, their TAMs, and their customer solutions managers. They can help with the POCs. They can help line up specialist resources. I also heavily encourage anybody who hasn't tried it out, take a look at DMS and take a look at SCT, Data Migration Service and Schema Conversion Tool. They will be a gateway and help you move faster. Also, you can bridge the knowledge gap with AWS certification and leverage AWS professional services or partners to help you achieve your goals. And for those who want to start faster on Data Lake, call to action is take a look at lake formation. It can really help you save a lot of time. As the guys had mentioned today, some of these things weren't mature enough or did not exist when we started down this path. Today they are, and they will. These services will help you move much faster in that effort. I have a couple links up here on lake formation, EMR, and Redshift. Hope you'll take a look at those and dive into those further. We think they could be a big part of your success. Also, there's some more details on Redshift around how predictive analytics, real-time streaming analytics, and business intelligence can be at your fingertips. So we hope you'll take a greater look at these. And then we've also created an innovators page for you to take a look. These are case studies that we pulled from our Oracle migration, and one of them is on the data warehouse. We're also giving 2 talks tomorrow with a different team on the Oracle migration across all of Amazon, and we're going to go over that over in DAT 359 tomorrow. These case studies here are examples of how different teams use Dynamo, Aurora, Redshift, how they leverage DMS to migrate. So I hope you'll take a look at the innovators page. All the case studies are consolidated there for you. And then finally, y'all really took a lot of time to come here this week and learn, and so hopefully it won't stop when you go home. I hope you will encourage your teams to continue down training. Take a look at the certification for big data technology. We have a great certification on that and some new database specialty certifications that have launched recently. And you can validate your expertise with that certification and build value into your career. And that's another element of the equation here. A lot of people transition their careers over the last 3 years through this database migration and other projects like the Andes Data Lake. So we hope you'll continue training, continue building, and get better every day like the services do. And with that, I'd like to bring Craig and Naveen back up, and I want to thank them. Amazon pushes our services to the limit, and it makes it better for everybody else consuming them around the world. And so thank you very much. We hope you have a fun and safe reInvent, and thanks for coming to our session today. If you could, please complete the survey in the session, the survey session in the mobile app for us, if you could, and we certainly appreciate that. Thank you very much.
Thank you.
All right.